Inniscarra to see how the ESB generate electricity.
Hey, Podge.
I've run the
No, heavy metal. It's got our pieces.
No, it's not.
We want.
Don't forget to walk across. There's the hand scan already, you see the bus. And the other ones, we wonder where we are. We meet them on the way back.
Get out of it, Howard.
Video me! Video me!
Look what you're standing on, Richard. Eddie, Richard.
Let's see the bus going.
Go on, get in.
Isn't every day, every second, every minute of the year, there are 3 shifts here, 3 8-hour shifts. There's an operator in the control room and there's a HBA downstairs.
God's sake, why is that? Your national language, etc., etc.? No, I can see your eyes getting glazed, that's alright, it's okay. That's basically it, I suppose, except here, we have a revolving drum here, okay, excuse me. Here, this revolves once a week. And say we're on Thursday, well, what day is Friday, isn't it? Yeah. Okay, Friday, say just past 12 o'clock, see the scribe at the mark on it? We were offload, say, last night at Carrigadrohans. We're offload, so the level was way down. So just after 12 o'clock, well, actually that's slightly said wrong, we came up on load, so the tail race rose. In other words, if you have, where are we? Excuse me. Basically, this is here. Carrigadrohans. There. That's a dam. This is a generator. Inniscarra, that's a dam, which is up here. Okay, much bigger dam there. So our level there, 63.91. That means 63.91 meters above sea level. Sea level, it says out over here. Okay. How many feet in a meter?
3.
Well, okay, all right. 63.91. Now, what's our tail raise? 48.78. 48.78. There. So when the water goes through the turbine from 63.91, drops down to 48.78. All right. Now, okay. Now, when we go and load here, a lot of water will pour out from carrying and will rise that level slightly, and you get a little blip like that there. Okay. So that is what's happened here. Before we went and load this morning, that level, see that level here now, was down there. All right. But when we came and load, the level rose up. A lot of water pouring down through the turbine in Carrigan Road. We got that slight rise there. See there? See that rise there now? That's that rise we have to get in there. And dig into it. Take him. Talk about. Okay, right. Fair enough. 48.78 now. This should be slightly lower than that, but it's not. Well, it is, of course, it is, yes. Okay. Now, think of a lake being downhill. Okay, it's supposed to be level, but actually there is a slight rise. Now the water goes down through here now, okay, through our turbine, and we were off load here again until quite recently, and our level was way down there, look at. But as soon as we came on load, the level here, this is the level here, it said the level was there, the level will rise up to about there, because the water, the big bulge of water coming out as a result of letting water through our turbine. So that's why we have a rise here. We rose there actually from 1590. We rose about 4 feet in our tail race as a result of coming on load. And if you go out there now, the tail race is where the water leaves the turbine. That's out there. You will see that the water is way up. Okay? You got that? Now, if anything happens here in our turbines, supposing we get an increase in temperature in our bearings, it won't necessarily stop. We won't stop it. But we will check why it's getting high. Maybe the oil flow is cut down or something like that, or the cooling water maybe has something happened to cooling water. Well, whatever happens, we will get a red and a white. Supposing, let me see, grease pump. Like I said, the grease pump stops, and on unit 1, we will get an audible alarm. An alarm will sound. Okay, we will get a red and a green light up. Now the red light will stay up until such time as our grease pump starts again. Okay, and when it does start, the red light will go out, and that will stay on until you cancel it. So anything like that could happen that will cause a problem, neither the turbines or the generators, we'll have it monitored here. With an audible alarm as well, a hooter will sound up there. Okay? So we're fairly well covered in that. Alright? I'll let you go now. Okay? Right, off you go. And good luck to you. I hope you all get jobs. And speak Irish if you can.
Just go back here a small bit here. Just a small view of some of the spanners that are the tools that were used. Some of them are still used. The ones on the bottom, I haven't seen that one used since I've been here at all. The big one, like. And there's more of them in stores. But you see these ones you use now and again, you know, time after time. Back here we have the pressure chamber, called that. You have air in there on the top. And the square on the bottom in both sets, you have oil. That's for the opening and the closing of the guide vanes when they are open, for the water to come through. Every year the oil is taken out and the oil is filtered and cleaned, and the same oil goes back again. In that one it's the same since 1957. The only time the oil will change is that if there is a spillage of water in the oil, and it happened in this one about 3 years ago. If there's a leak in the pipe water, The whole thing has got to be disposed of and new oil put in, but it's the original oil since 1957 in this one. You're okay? Good of it. This broke open here. Break this open and the whole shaft was all the way up. That was the first time that was done since 1957. But this, nothing else moves here, only there, the road. In behind you here are the panels in there, that's where all the windings are. Those are cleaned every year, maybe every second. Dam gets, if the dam is unsafe, like, you know, you can see that there's a job being done on it there from maybe 10 or 12 feet from the water. That's a new, I think it's a 6-inch slab of concrete in more safety. That's only done this year. And it was a firm from Limerick that done it. The gates above, of course, are all steel, pure steel gates. Follow it right up to the top. 3 boxes above on the top. That's the bridge, we call that. Those 3 boxes, you can open the gate by a handle as well. You could have 2 people on the massive big handles and opening the gates. They're tested every year. They're electronically tested as well then, so that they do operate. That if there was cause to open the gates in excess water. That's done every year. And what I said, that spilling is never done because you're wasting the product, which is free. Go to the pipe here, the black pipe in front of us here, and if you follow through the first, we call it a window or a door, you see a little barrel shaped inside with a lot of green moss on it now. That's the fish pass now, and you probably can't see it now with the generation the water is doing, the turbulence there. That pass could be open now, probably is open. So what happens, when that's left open, the fish will go in there and they will stay inside in the barrel or the bowl inside until the gate is closed there, as you once said there in the video. Her name now, Sienna. And then what happens, the water will actually rise all the way up to where the chap is just passing above now. That height now where he is there, that's for catching the fish. There's a basket attached to that, and that goes down when the water gets up to the top. With the inflow of water, if they're not catching the fish at the time, they are now for the hatchery in Carrigan Road, the fish will automatically jump out again in the water. The fish will go again in the water. Can't think the time to go that now. At the moment they are catching the fish for Carrigan Road, and they got a lot of fish one day. They got about 256 fish one day, which is, I can't remember getting as much in one day before. But they catch them there up to, say, Christmas week or the week before Christmas, and they start the cycle with the hens and the cocks fish outside in Carrigan Road. They call that stripping. They strip the goulash or whatever you want to call it out of both species of fish, and they start the cycle out. And if they have too many fish, then I said that they will automatically take them around the different rivers, and they take them to Galway and take them to other parts, like, you know.
So what is coming up there now? That's coming through.
That's coming through, all coming through underneath you there, on the river here. You see them 3 gates there, like.
Where were we down inside now? We went in too much in there, down on the level of water.
Well, you would be just about the level maybe, because you would be on the level because the wind is there. What's the first floor by the control room? You would be, you would jump. And then you have the head of water, which is, there's still a small seepage when they were opened. There's water up in there now as well. If you take a look over here by the stones, we'll go to the yoke on the right of the stones where there's a wheel on top of it there. That's called a scour valve. That's a cleaner, it's a cleanser. It cleans, it's put on maybe once a year, twice a year. It cleans out the toe of the dam. That's if any dirt, silt or anything like that will form on the bottom of the dam, that this will clear it all out. And if anyone else here on the day that it is on, when it's open full, will throw water to here. And like, a lovely picture to take if you were here tonight, we'll bring water to here. Back to this.
How long did it take to build it?
5 years, 52 to 57. 52 they started in the commission in 57. But the stones were put there because when there was excess water and they had to spill, the turbulence of the water was coming here underneath us along here, where we are all standing here now. And they were afraid over a period of time, as you know, water is going to be, it's corrode, everything water goes through will corrode after a certain time. So they put those stones there, and when they're spilling now, that breaks, bang again underneath us here, if you want, you know. That it has an effect on the rains. So how they put them stones, they made a roadway along here, And of course, it had to be in the summertime, that there was very little generating. But in the summertime, that if, for instance, there's no water, there is no generation, the fish will have to have oxygen that are in the river. And they have to have the small set. The small set can generate at a 0.5 megawatt. The big one can't. The big one has to do 4 megawatts. So it's a waste if you can. 4 mightn't be needed.
Yeah.
But if the small one is out, you'll have to use it. But mostly the small one is on right through the whole summer if there's no generation. You might have 6 weeks that there'll be no generation. It's the power is advantage, you know, heating and everything's cut off and all that, like. Then yeah, that's where they made the road along there.
Yeah.
And it was all done. And I think that cost nearly $250,000, I'm sure. But what you can see there is there's a steel wall, unbelievable amount of steel on the outside of the rocks there, as you can see. And they had 2 cranes actually putting all them stones into place, like. It's all it said in the video there about the new spillway that's done in Kerry that cost about 2-something million, and they are waiting for the 1,000-year flood, like. But we have some hope to meet you, but you're seeing it, we don't know. But it will never be tested. It's a lovely job, like, to see it, like, but it will never be tested. The hydrometric man here now, Jim O'Neill, he's from Castletown. And I said, will that ever be tested? He said, no. He said, they're waiting, whoever will see it, he said, to see the flood. I thought that they'd leave the lake fill up, like the lake can fill up when there's no generation, to gradually fill it up to the red mark, the danger point.
Yeah.
I said, there's only about a half foot to go. He says, no. He says, that you have to stop at that, he said. And unless the massive flood will come, but I don't think none of us will see it anyway, but you don't know. Anyway, you'll have to go looking for the coach all the way back now to Dunmanway.
Yeah, we've got the other. We're finished here now, right?
Yeah. They must be done by now. Unless they're eating now, they could be eating now. Your dinner will be gone.
Well,
You're fixing it. You're gone. All right, Sonia. Bye now.
Oh, cool. It's in there. It's green. Look in there, Mox. Go in there.
Yeah.
I'm sorry.
Don't breathe back.
And it compares it to the unknown through the graph, so it estimates then what the result of the sample is. It will do 7 analysis at one time. We do 4 at one time, and then we use the other 3 independently. We can do ammonia, phosphate, nitrite and nitrate at the one go. We can do about 60 samples of sample for analysis, which is a big change from over 10 years.
The probe move around, don't they?
The probe is, yeah, we get the 12 number. You can move the probe to the chest routine to any position in any direction.
Open our insurance if we go to stream now. To screen There's all white powder in it. There's a hash. Or there was a cocaine factory after go up and smoke one. Where? On hill. This is link that they get their paw from the air. You see those paw good things that also you just disconnect all of them and plug into some blood.
Reservoir. Water titrator. And it measures the amount of mils going through. It does all the calculations and they're needed in a particular instead of using the burette and having to calculate things out in the end. That's an automatic competitor. You put that in the end of that and it draws it up.
Good job. There we go.
Who takes those samples from the rivers?
We do, ourselves.
Go down doesn't it?
Yeah. So we know every sampling point where it is, what's around it, if there's a stream upstream of it or a town upstream. Did you get this to move?
Is there any sampling around the area?
Sample 113 statements around the night. All the cups have numbers, so that's rack number 2, cup number 16 can do. As well as that, you put the sample identities. Every sample that comes in gets a number. You can put the numbers in on the computer, so that every sample it does, it knows the number. And you can relate.
Do you do anything to stop pollution?
We've done a lot. Generally, large-scale pollution has been practically wiped out. The main problem now would be fertilisers spread on the land and washed in. That is the main problem. That's very difficult to. But I think people are getting the idea too that there's no point in putting fertiliser on the land if it's going to be washed off, or if there's too much fertiliser there already. I mean, it's only costing a man money to do that. Agricultural pollution would be the main cause. But that's changing a bit now too.
Actually, it's lunchtime, and it's going to be very hard to concentrate. But the canteen, unfortunately, is full at the moment. We've got another. Is it a different school? I think.
No, our school now.
Yeah, but it's actually packed. So we'll run you around the waterworks in double quick time. I won't explain it to you very much because you've seen the video. I hope you probably got a grasp of it. So I just want to show you where we are and where we're going to go. We're just going to go. I just want to show you again. Maybe it was on the video, but very, very quickly. Okay. The water is pumped from the lake here through this intake tower, which is down below us, into this pumping station. There's 2 pipes here, 1.5 metre diameter, right up to the top of the site into these 2 tanks, which are raw water balancing tanks. The water flows down through the treatment works, where we add coagulant here. The settling tanks are here, the sand filters, and then the post filtration where there's chlorine, the lime, and the fluoride is added. We'll just go up here, have a quick look at that area, have a look at the settling tanks, have a look at the filters, and back down, and then you can have something to eat. So just follow me. That's down. This way.
Rich,
Into the 2 tanks above us here on the top, these are the raw water balancing tanks. So the water is allowed to flow from those 2 tanks. The water out of the river, right on the lake, is flowing from those 2 tanks down underneath us here in 2 pipelines. Okay? Sorry? No, it's not covered. It's an open tank. 2 open tanks. We add in alum. You probably saw it in the video to coagulate the water. Okay? The alum is a liquid form, and we store it in those tanks here on the right hand side. So it comes in bulk tankers, 20-ton tankers, and we use that for dosing it in. You can see that as we go. That's alum. Aluminium sulfate, or alum for short.
Doesn't matter when it's outside.
It doesn't matter when it's outside because we have to bring it down in solution. We have to make it a much more dilute solution inside.
Jump in now.
The Allen outside is transferred back into these two into the 4 tanks here, the day tanks. And we add in water here to make it a suitable solution for dosing. And these are the pumps for dosing the water into the Allen bin. If you look over here, please. There are the 2 pipes where the water comes in from the raw water tanks into the treatment. What you see now is that this one is closed off, the other one is being used. We've got a valve here which is operated by air and it's automatically operated to allow the right amount of water through. The water is flowing through 24 hours a day. We try to keep it at the same rate. At the moment it's 10 million gallons a day. And the alum, you can see small pipes at the side here. Well, the first pipe here is where the alum is dosed in. So it's actually being pumped in there at the right amount all the time, so that you have a coagulation process happening. We also added soda ash on occasions which is needed for alkalinity because it's a chemical reaction. And then the water goes from there in. We need to mix it up rapidly then so that the coagulation and the flocculation processes start. And that's done inside in the next tank, which you can have a look at. It's called the raw water contact tank. Now what you will see is one of them is empty, this one here, the other one is in operation. So you have 2 tanks, so you can see what they look like, empty and full. The water will come in, goes into the water. And then
Does this take the colour off of it or describe it as?
well, the whole idea of the coagulation is to take the colour out. But you would see the water now before the colour is taken out of it. The river water as it's flowing in, but that's what you'll see up here. So we just take a very quick walk around. The weir at the 2 tanks are exactly the same. You can see the water comes in through a screen and up over the wall and gives it good mixing, flows out over a weir at the end. The weir is there to measure the flow. The height of the water over the weir will tell you how much water is flowing over it. So we're measuring the flow there. You could see a little yellow thing there which was an ultrasonic sensor which is actually measuring the height of the water, and that's how the water is measured. And the flow that's being measured there is controlling the valves there that you see on the big green pipe, so that the right amount of water is coming through. The other water you saw flowing in at the weir in a pipe is polyelectrolyte. That's another chemical we add, which is a flocculant aid. It helps the flocculation, which is the coming together of the particles so that you can settle them out of the water. Where all the colour is trapped, is brought out of the water in the coagulation process, and those particles come together in a flocculation process and they're settled. Bags of white powder, and they're the poly preparation units there. It's an automatic system. You just put the bag in at the top and the poly drops down and it's mixed up with the right amount of water and it's pumped in. There's pumps there which pump it back up. What we have here behind us then are soda ash tanks. I was explaining that that's added in on occasions for alkalinity, especially during the winter time after we've had a lot of heavy rain. We have to add that in at times.
last question.
And that's what
You want that
yeah.
Yeah.
We've got one here which is out of mission at the moment for cleaning, so you can see what it looks like. The other three are the same. What happens is the water comes in at the bottom, down through a central channel, out through the pipes at the bottom. And there are holes in those, underneath those pipes there are holes, and the water flows out. And that's to distribute the water out evenly over the whole tank, so that you've got an even velocity over the whole tank as the water fills up, comes up through it. So what happens is the water flows upwards through the tank. So it's an upward flow clarifier they're called. And it's, what happens is the block that's formed forms a sludge blanket, as it's called. The water that came in through the settling tanks, right, sedimentation process, the water flowed up to the top and it was collected in the metal channels on the top. The water that came in through there is all collected into one channel and brought in here. So this water now is the same water you saw in the contact tank, except the solids have been settled out of it. So most of it has anyway. We're going to get a few bits and pieces coming through, but the whole idea there was to take the colour out of the water. So you can see that the colour is pretty successfully taken out at this stage. So the next thing now you want to do is to take out any other particles that are left in the water. And you do that by going through sand filters. And the sand filters will take out very, very small particles. So this channel here is using the high flow to the 8 sand filters that we have. The tanks outside the windows here on each side are the sand filters, 4 on each side. The water flows out here, down through the centre of the sand filter and down through the sand. The sand traps any particles that are left in the water. We actually have a little model here which we'll show you as we're walking by. You have to be very quiet so we go down. If you go around to the front of it there, you'll see it shows what the sand filter looks like. Okay lads, if you move right back please so that everybody can see the front here. There's the glass front. This is just a little model. Keep moving back there please lads, you'll see it. Move back. It's a model of a filter. Gotta move back a little bit. The big sand filters on each side of are made up two sides. You can see the sort of the shape of it. Basically, the water which is settled, okay, flows in through the centre and up through the centre of the tank and over the wall and down through the sand. It flows down through the sand here and is collected in pipes at the bottom of the filter. So in each of the sand filters, we've got about 900 millimetres of silica sand. And that actually traps any particles that are left in the water. It actually can trap particles which are 100 times smaller than the actual sand grains themselves if they stick onto the sand grain. So that really is polishing it up, making the water very clear, taking out the smallest of particles. The other thing about the sand this is a rapid gravity sand filter. And that is the difference to the slow sand filter. It's rapid gravity, we can put more through it, but the other thing you can do with a rapid gravity filter is you can backwash it. What happens is obviously as you put water through it, it tends to get clogged. Particles get trapped. So the water won't go through it as fast. So it builds up here. So you can stop it then after we stop them every 2 to 3 days and we backwash them. We can force water back up through the pipes and up through the water and force and clean out any of the flock that's trapped in it and take it away into the drain and down to waste. We actually have sludge treatment facilities down further on the site for treating the sludge that comes off the sludge bleeds out of the tank and also the sludge or the waste water out of the filters. So that's the waste, and then the treated water is collected in a pipe gallery underneath us. And then there's 3 other things we do to it. And if you can name them, we go straight to lunch. After filtering the water, we collect the water underneath and then it goes off. What else would we do? Right? What's the line for? It's for bringing up the pH so that it's not corrosive, so that it won't corrode the pipes. What's the third one? Chlorine. What's that for? Disinfect the water. Excellent. These tanks outside the window.
There's no need to go, Bonnie.
Lunch. But that will be again. That will be trapped in the side.
You have to backwash every 2 to 3 days.
Yeah. And that's not much, like. Some places would have to backwash them a lot faster, more often than that every day. City would have to wash them. Some of them are 2 or 3 times a day.
And how long would you be backwashing?
Takes about an hour. Well, 20 minutes to an hour.
Is chlorine gas or liquid?
Well, it's pressurized. It's a liquid in the pressure in the tanks.
Yeah.
Pressure.
Oh, yeah.
It's
gas.
at normal temperatures. It would be a gas under atmospheric pressure.
Yeah.
So when it comes out of those, it becomes a gas. And the pressure is reduced. And then it's you pour water. You pump water through. It's injected into a stream of water and make a solution. And then that solution is got underneath it here. You pour the chlorine gas in. It's chlorinated there for just before it goes. Into the reservoir and it's up here. There is another one for operations.
This is Inniscarra lab. The microbiological lab. Would you like to have a quick look inside? Yeah? Okay, just...
Connor, it's got a bacteria. Bacteria changes the colour of the paper.
Okay, here we do the microbiological analysis. First and foremost, the most important thing in this laboratory is that everything is sterile. Every evening we have a lighting system put on here which sterilises every top of everything in here. There's a switch over there under the grey boxes. When that gets turned 180 degrees from where it is now, these normal lights go out and UV light system comes on. And basically when we come in the morning, that system is turned off, and when we go to analyse the sample, we assume, because the light system has been off for more than 5 minutes, that everything is once again covered in bacteria. These are the plates which we use. This is for total coliform, fecal coliform, strep. We place the membrane on these plates, and the media which is in these plates then works its way up through the filter and feeds the bacteria which are trapped on the upper side, thus allowing them to grow. Each one of them started from one.